Hello viewers, welcome to my channel. Learn with Mr. K. Please like, share, comment and subscribe. Today's topic is load balancing. Let's get into the video to learn about load balancing, its functionality, uses and different types of load balancing methods. What is load balancing? It is a process of distributing application network traffic across multiple servers to optimize applications availability, user experience, and responsiveness. This process ensures that no single server is overloaded with network traffic. How does load balancers work? There are multiple types of load balancers available to satisfy application requirements such as scalability, fault tolerance, low latency, high availability, and performance. As shown in the diagram, a load balancer sits in between client and server to evenly assign tasks to servers. Load balancer serves the application traffic by considering server health, traffic load, response time from each server, session persistency, geographic location, and few other factors. It is important for load balancer to consider these factors before serving traffic, as they determine load balancing in application. Server health factor for load balancer helps to identify whether to forward network traffic to a server or not. If the server health is not good, load balancer will make necessary changes to route the network traffic to healthy servers only until it is recovered. And thus, this also ensures high availability and fault tolerance of your application. Traffic load. Load balancers monitor the traffic on each server, which could include metrics like CPU, memory usage, network bandwidth, and the number of active connections. For example, if one server's CPU usage is at maximum capacity, load balancer might route traffic to servers with lighter loads. Response time. Load balancers measures the response time for each server, which is the time it takes to process a request. For example, server with the least response time gets more requests than server with highest response time. Thus, load balancers improve user experience. Session persistency. Some applications require users to be directed to the same server during their session for consistency. For example, e-commerce website will route a user session to the same server to maintain the user's cart state and login credentials. Geographic location. Directing traffic to nearest server based on the user's physical location to reduce network latency and improve application performance. Load balancer architecting. To get most out of your application, we can try to balance the load at each layer of your application, as shown in the diagram below. We can configure load balancer between client and web server and application server and shared resources, such as databases. And as per the requirement of your application, we can place the load balancer in all these places, and thus we can improve the performance of your application. Types of load balancing. There are different types of load balancing methods available for each use cases. The choice of load balancing method will depend on application requirements. Please feel free to pause the video to go through the table to understand about each load balancing method. DNS load balancing. This method is used to distribute traffic at DNS level. This is best suitable for geographic distribution of traffic. This is simple and cost effective. Traffic is evenly distributed to the best performing server by DNS response. This focuses on load management and redundancy. This is like a reservation management in multi-branch restaurant chain within city, like allotting reservation to the customers based on their location, availability, workload distribution at restaurants. Hardware load balancing. This is run on dedicated hardware in on-premise data centers. This is very efficient, specific optimization, high cost and less flexible. This is like having dedicated traffic police to direct heavy vehicles in busy intersection. Traffic police is always present, irrespective of heavy vehicles coming or not. Software load balancing. These are run on standard servers, best suitable for cloud environments, more flexible, cost effective, best for small and medium size businesses, easy configuration. This is like multiple chefs in a restaurant. Only when on new order and the other chefs are busy, a new chef engages to cook. Otherwise, chef is idle. Layer 4, transport layer load balancing. This operates at transport layer of network, like distinguishing type of network call, TCP or UDP. TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol. TCP network calls are for web and UDP network calls are for video streaming. These don't care what data is sent and what is received. This is used in high-speed, simple routing needs and for fast and efficient, low overhead requirements. A small analogy for this is like a multi-lane toll booth, allotting lanes for cars and heavy vehicles without any inspection what's inside. Layer 7, application layer load balancing. This operates at the application layer, inspecting and routing traffic based on content. Its use cases are web applications, content routing. It is best suitable for intelligent routing based on application data. It has its own limitations like higher overhead, slower performance due to deep data inspection as it validates the data that is coming from the server. This is like walking into a restaurant with a receptionist. When you first reach, you answer questionnaire like preferences on food, seating. Like this questionnaire helps to serve you best with the proper routing into the vegetarian or non-vegetarian, family or corporate sections. Round robin load balancing. This distributes the requests sequentially across servers. This is simple load distribution on a set of uniform server capacities. This doesn't count the server health or load differences. This routes the request in a sequence like request 1 to a server A, request 2 to a server B, request 3 to a server C, and request 4 to a server A. It's like a cyclic process that continues till all the requests are acknowledged or processed. Weighted round robin load balancing. This assigns the weights on servers for unequal load distribution. This optimizes based on the server capacity. More the server capacity, more the weights. This works like server with high capacity should serve more load. Like server A has higher CPU memory will serve more load than the server that has less CPU and memory. Least connection load balancing. This routes requests to the server that has least number of active connections. Efficient load balancing with fewer busy servers. This is like sending customers to the cashier with the fewest people in line. Least response time load balancing. This routes the request to the servers with the least number of connections and low latency. This is best for latency sensitive applications. This is like going to the fastest moving line at the checkout counter. IP hash load balancing. This uses hash to the client IP address to distribute the load. Traffic is routed to the same server every time. This method generates a hash key based on client's and destination's IP. This key can be regenerated if the session disconnects. This will maintain the session persistency. This is like a restaurant where the same waiter serves a returning customer. Geographic load balancing. This distributes load based on the user's geographic location. This will reduce the network latency and improves reliability for global users. This is like Google directing searches to the nearest data center or Google Cloud regions. Failover load balancing redirects loads to a backup server when the primary fails. This ensures high availability, redundancy, and reduces downtime. This is like a backup generator when power goes out. This is actually or usually used for the backup for the load balancer. If one load balancer is down, a second one will kick in. Elastic load balancing. This will dynamically scale based on traffic demands. This is best suited in cloud environments, highly scalable and cost effective for variable traffic. Generally, its pricing is like pay as you go. This is similar to software load balancing with more flexibility in integrations with cloud providers, scalability and fully managed. Whereas in software load balancing, cost depends on software licensing, custom integrations and configurations, independently deployed software. A good example for software load balancing is HA proxy or Nginx. And for elastic load balancing is AWS ELB, elastic load balancing.